Hello, Derek. Hello, Sachin.
Hey.
Hey,
So I have done work reconciling uh, Apollo Federation rules.
yeah, I saw
Yeah,
that you opened up some PRs. I didn't get a chance to look at those,
yeah,
but
yeah,
yeah,
yeah.
it was with the requires and interfaces. That is, for ours, like in a full federation, since it's separate fields, right?
Yeah,
We just basically rejected because of that. But with the composite schemas, with require and arguments, that's a good call out. That it actually has to
yeah,
be validating that. Yes.
yeah, and also but I'm going into that. We discussed that like on requires, you can have constant arguments. We
Mhm.
had the same for keys on the composite schemas. But actually, I looked up that Apollo Federation cannot do that. But we can talk about that.
Yeah.
Yeah, and then because Pascal is also coming, sorry, we just doubled ahead. Let me check if he's coming. Are you coming? And let me also ping Kamil if he.
Mhm. How are folks dealing with the heat wave? Is already done with the heat wave in Europe or still there?
Holy shit! It's like dealing. It's like last year. My brother and Pascal really bought air conditioners. So traditionally in Europe, you don't have these
Yeah.
things. Like in the US, it's everywhere.
Mhm. Yeah.
And I'm also like, nah, maybe I don't need that. And I did it again. And now I'm like, shit,
You're
this
getting the
winter,
air conditioner.
I'm going to get one. I don't
I'm
know how
based in I'm
Finland.
based in Scotland, so
Yeah.
not much of a problem up here.
Oh, you're still, but London is also pretty hot, right?
Yeah, but I'm 500 miles from London, 500 miles
Yeah.
north. So yeah,
Yeah. Yeah.
it's been like 26 degrees here at peak, which is perfectly fine
Yeah, that's nice. That's nice. Yeah.
Where are you in Scotland?
in Edinburgh.
Edinburgh. Oh, nice, nice. Yeah, yeah. So my wife is from York, if you know that. So
Yeah,
it's pretty north, uh,
it's about
but
halfway between.
yeah, halfway between. But the problem is that the in between is just single roads.
Well,
Like in Scotland.
yeah,
Yeah, go
North
ahead.
so York, sorry, is famous for, well, to me it's famous because when you're taking the train from London to Edinburgh, London to York is high speed, and then you go down to the slow like shuddering train to Edinburgh. That's the
Exactly.
Sam,
sad thing.
Sam, I think Zoom is using your not good mic.
I've got like six microphones at
I
this.
know.
At this.
Well,
Oh,
Zoom is using the one that
you're
isn't
right.
using Zoom.
1 second.
Here? Better?
Now you sound absolutely delicious.
There's Pascal.
Fantastic. Thank you, David.
Okay, I think now we are complete. Let me actually quickly share my screen. And then, okay, Sheen. We are one missing, one short. Sam, can you file a pull request and
I
add your
think
name?
I think David put one in for me.
Really? I
Yes.
might have deleted you because I did the
No,
merge
I
picking.
was
Okay.
I tried to add it to my PR, but then literally the second I added it, you pulled it in, and now I'm in a big mess where I need to rebase things. So I'll make it as soon
Okay.
as possible.
Yeah, it's just for completeness.
No, of course.
Awesome. Okay, let's get started. Before we start, let me remind you that we all agree to the GraphQL Spec Membership Agreement, the participation guidelines, and the contribution guide. Also, we all abide to the code of conduct of the GraphQL Foundation. Also, meetings are published to YouTube, so they are recorded, published to YouTube, and we are using LLM for summarization. So just be aware. Let's do a quick round of introduction. My name is Michael. I'm the host today.
Hi, I'm Pascal. Next is David.
Okay. David from Undergraph, hello.
Hey, it's Derek from Apollo.
And Shin from Apollo.
And I'm Sam from Wondergraph, just joined, so learning.
Yeah, awesome. So I have added already a lot of topics. Does anyone else want to also add a topic?
I just wanted a quick question to Sachin, whether he's been able to look at the couple of things I flagged. If not, that's also fine.
Yeah, from the issue they mentioned last meeting, I do have a fix almost ready for the super typing issue. It'll be made in the Rust repo instead of the JS repo, or the Rust composition instead of JavaScript composition, but there's a fix going for that. So yeah, I have not looked at the provides issue yet though. That one for satisfiability, I haven't checked that one yet.
Awesome. Okay, let's get started. So, like, I'm really pushing to get the spec finalized. There's a lot of details, and we got also a lot of feedback from people who tried to implement it. For instance, Andy from GraphQL Java implemented a Java version of the gateway and had a lot of feedback with questions. So I'm at the moment baking in all the feedback we're having. The first thing, and I think this is maybe a quick one, is I'm writing a introduction at the moment to what are entities and what is identity. Basically, what's the difference between resolvable keys and non-resolvable keys, and why do they exist? Like, just to get people into what actually is the difference between a lookup and the key declaration. And let me actually look at that. So this is just a small introduction what this is. And if you have time, go over it, give feedback. Text might need polishment, but it's one start on that. So where it gets more interesting is we are looking a lot at the moment at backwards compatibility, that you can adopt the new specification, but being also backwards compatible to Apollo Federation. And for that, we are looking a lot into behavior that we have in Apollo Federation. For instance, one thing that I just picked up is that keys cannot have constant arguments. This is different to what we have with requirements. And maybe I'm wrong on this, but that's the read I got from the error codes in Apollo Federation. That there is essentially a difference. Let me just go here. ID has field arguments. Do I have an example?
Yeah, it is different. So like the requires can have default values, but the keys, they cannot have any arguments.
That's right.
Yeah. Okay. So I have, because when we discussed a while back, also with Martijn in here, I think this distinction we didn't include. So in the current version, this is possible. You could have a key that has a constant, right? And I like this PR is about removing this capability and basically saying that we have the same violation in the validation as Apollo Federation has there. So if you write a key, then it cannot have a constant argument. Whereas if you have requirements, then you can have constant arguments. Are we good with that?
Sounds good to me. Yeah. Go ahead, David.
There's one kind of, I don't want to call it an edge case as such, but you know how you could define an optional argument in one graph, and then in another graph you don't define any arguments at all. And the key is validated against the subgraph it's defined in. But still, if an argument is defined in any subgraph, it becomes an invalid key regardless of being validated against the subgraph itself. Am I making sense?
So you mean if scope were nullable here, then scope would be allowed because like null is an implicit value, or
so I'm saying, imagine you had two graphs that have a field like, I don't know, like object and then ID or something.
okay, you have
Because this is going to be an entity key.
product, right? And then we have what field?
So let's just, if we did field key, and then we gave it type key, but it would need to be, if you give it type like as in a new object key.
Okay.
And then if we were to make now an object key, and then let's just say this was ID and ID. Yeah.
And
so in this graph, we could give product a key that is saying the key has the value key and then selection set ID, and that would be fine.
almost.
Yeah. So this is all perfectly fine. So now if we imagine we had a second subgraph with only key in it, like we don't need to talk about product at all in here.
Oh yeah.
And here key actually defined not key, sorry, ID on the field there. The ID field defined an optional argument. This would be an invalid. This would be flagged as an invalid key, even though we would validate against the subgraph, the first subgraph, that the key doesn't has an argument, but because another version of that field has an argument, it would render that field invalid, that key invalid, even though the argument itself is not defined in this subgraph.
Yeah, but here's also field merging rules, right? Field merging rules would say that both have to have an argument, or
if it's optional, you can do this.
Yeah,
but that's fine, right?
yeah, that's fine.
Like if it's a required, then field merging rules would explode anyway.
Because what the rule that I just specified means is that you cannot do this.
No, correct. But my point here is that the validation of the key has to be on the subgraph level, but it also has to be on the supergraph level. Or at least it needs to take into account the other subgraphs that could contribute an argument.
Why does that matter? Because the arguments are
Optional.
Yeah, and they only intersect. So
correct. But I'm saying this at least this is how it works in Federation today.
Yeah, but that doesn't matter. Like the key is validated locally, it's valid. And then can you make the foo string required on line 12?
Yeah, of course, but this wouldn't compose, so that's a non-issue. I'm just saying the validation process currently in Apollo Federation would take into account other subgraphs that contribute to that field.
Yes. So, but what I'm saying is, like in Apollo Federation, this couldn't be used as a key
in another graph, correct?
Why, Derek and Sachin, is this a behavior that you have reasons for, or is this just so that you have a better error?
Sorry, I'm muted.
I would have to double check on it because technically those would be merged to ID without the argument.
Yeah. They should be, because it's an optional argument, and some things don't take it. You kind of have to merge in the supergraph schema to one that doesn't have the argument, right? Like the supergraph
Yeah.
shouldn't have foo in it, right? So I think we should allow this, or is that, if I remember correctly, for at least the subgraph validation rule, like it only checks the arguments in the subgraph. So it ends up being okay here, and it only checks whether it doesn't check the definition. I think it checks the field, or it checks the field instead of the field definition. So I think it's okay, but I have to double check. Maybe this is
Yeah,
another thing where
because I would also say it should be allowed, right? Because if its foo is being dropped, it's not in your super graph or API schema anymore, right? So that's seems like it should work, but
Yeah, because like I mean, these fields when they are merged are semantically the same if no argument is provided. So they should be, in my opinion, be able to carry a key.
yeah, as far as I'm aware, I believe this should compose, but I don't actually know until I've tried it, so I'm not sure. Like I just remember the subgraph validation rule I think checks args, but instead of arg defs, and I think it runs at the subgraph level instead of the supergraph level, or like it checks other subgraphs, but I'd have to double check to be sure.
I'll
But
I'll I'll
but
double
your
check.
argument was also not composition; it was like runtime behavior, right? That it would not be used at runtime as a key, or at satisfiability would not be used as a key.
For satisfiability would not be.
Because,
Well,
like, as far as I understood David, he said this would not be considered as a valid key provider. And that means satisfiability would need to drop it. Like if it's not considered as a key, like this path through the second subgraph is not possible. Is that correct? And I would not do that. I would, like for the composite schemas, I would just say we would consider it as a key.
so satisfiability would run against the, the merged supergraph though, right? So when you merge those keys, the ID fields drops the argument because it's, you can. Like if it's a required argument, it wouldn't compose, but if it's an optional, it will be dropped. So
So to be clear, I'm going to double check, but I believe that this would fail. So we're not talking about runtime. We would never get to runtime because I'm proposing that this,
Satisfiability, I mean.
before that even, I believe this just wouldn't compose, but I will double check. But there's also the other case where arguments are not involved. So another illegal thing in a key is an abstract type, right? And I know we had opinions in how composite schemas will deal with coercion with abstract types. So, one graph you have an interface, another graph you have a concrete type or an implementation. But you could run into the same issue because I actually forget the rule. If you have an interface in one graph and a concrete type in another, I believe the interface type wins over, right?
that's right.
So
For return types.
imagine you had a field in one graph that returned the concrete type and it was used as a key, and then in another graph it returned an interface. It's valid against the subgraph, but it's not valid against the supergraph. And this is a similar situation when I'm describing here, where you have to consider all the subgraphs, even post-merge, pre-merge, sorry.
Yeah, I'd have to double check whether we check at key against at key fields against the supergraph schema type. I'm not sure honestly, with that validation, but I'd have to check to be sure. But you're right. There's an edge case to be checked there of when the key field or ID in this case returns an object type in one and an interface type in another. Let's say it implements, and the key might be fine in the object type. I'm not sure if later the composition will error when it sees that it actually is an interface type. I'm not sure of that. I'd have to check.
Like this is like a crazy edge case, but like in theory, someone could do it.
Yeah.
Awesome. So, but like again, in the like GraphQL Federation spec, here, we would just consider it valid.
Sorry.
Or is there still like that? This
Well,
could
this
be.
case, I mean, yeah.
I think
Yeah.
this case should be valid, yes.
Yeah, yeah. This
I
case, I think.
mean, specifically this one isn't, right? Unless you have a key on
I just
the
checked.
second.
I just checked and I'm wrong. This is acceptable. So as long as in the supergraph it's not propagated, it looks like it doesn't, like, as long as it's valid in the subgraph, it's fine. But the other case I brought up, the abstract type, I think that will be a problem.
Okay, so this one here, I mean, specifically this example wouldn't work because it's not shareable, right? So we would have to have it as a key or shareable on the other subgraph as well.
Yeah, it would need shareable on the other subgraph, but otherwise it composes fine.
Yeah.
Now it composes.
Uh,
No. Now it composes.
Yeah. Yeah, I didn't want to nit here, but
that's valid. So, you know.
Yeah. The other question is, can you show me the diff quickly? Did you say that we allow for, so the PR says forbid fields with arguments in key and in is this PR title still
forbid fields with arguments key and is? Yeah.
Okay.
So the idea is, like in both, like in is, you are not allowed to, because like in the requires part, you are allowed to use in this, because this is the same selection set map that we use in requires. So I needed a validation rule to say, okay, it's this is not allowed here.
We were talking about the selection set map in a different use case. That's why I was confused. Fine.
Yeah, this is a lot of where I'm at the moment iterating on specifying this, tightening the specification on these things. Okay. So this is number 2. Yeah, this is more in taking the easy ones first. Sorry. This is more, I think, that we weren't fully clear. Let me just quickly get it back onto my stack. Yes. So there is some technicality in and because like we are defining these lookups, right? And with lookups, you always have, also you also have the same problem with lookups, right? But you kind of specify the key already on the lookup. Depending on which lookup you take, this might not be there or this might not be there, depending on how your data structure. It's more also edge casey. In many cases, you would maybe have both in your database, whatever. But here's the difference. Like if you have 2 keys, then we also need external for the keys. And before we were in a direction in the specification where we basically said that external is a sibling to provides and not anymore key. But actually, it needs to work on both ends. Like you need external still for keys, because technically these could have 2 different data pods, and maybe this has UPC and this has SKU, and that means depending on the case that you're querying, either of them might be external. And this is also like with the entity and identity stuff. You could even have fetchability by a key without actually being able to provide the same key.
That's right. At least we call that in Federation. So,
yeah. Okay. Yeah. Yeah, yeah, that's also, I think we are aligning now closer on top of that. Okay. The last one, and that is the more interesting one. This one. I also have to read into this again. Oh yeah, this is a bit okay. This is maybe a problem that Apollo Federation doesn't have in some cases, because in GraphQL Federation we have the ability to inject requires into arguments, right? This then also, if you have an interface on a subgraph, this basically concerned on a subgraph. You have on a subgraph an interface, and you have 2 or 3 implementation, and you put on one of the implementations requires in, right? This doesn't work. So if you put a requires argument into one implementing field that you get from an interface, you basically need to also put it in the interface and all implementations. Otherwise, you're not compatible with the GraphQL specification. This is part 1 of it. You see, do we have that here? Yeah, so here we have account. You can see we have the requirement here. And this requirement is basically inherited then to all its implementers on this subgraph. On another subgraph, you could have other things. This, like when we talk about interface object, I've started to work on that. Then this is not an issue, because interface object is an object type on that subgraph, and you don't have an interface to that, so you're free on these fields, right? But here you, like on schema A, for instance, you need to inherit this string.
Yeah, otherwise you won't be able to have the arguments on interface fields.
Yeah. Yeah, and I didn't want to like introduce language where we have to loosen GraphQL core validation for the type system. I mean, would be one route you could take. But I think it should just work with any GraphQL server out of the box. And then you have this condition. And this is like in Apollo Federation, you technically don't have this problem because you pass it through representation.
Yeah, it's no problem because it's a separate field. So you just annotate the field with requires, right? And it's a separate field. So it's a problem because it is an argument. So yes.
Yeah, I thought along this, and we discarded this idea in the beginning when we started discussing this, as you could also have top level requirements. So in the lookup, you pass the requirements down, but this doesn't scale. And this does scale, but you have this additional hoop to take.
Yeah, adding a validation rule, I think it's the simplest thing to do. Sounds reasonable.
Yeah. Okay. So these are the topics I had for today. You can go through them. I have 3 more PRs in various stages that I will commit over the next couple of days. But yeah, go ahead, David.
So it's slightly tangential. So if it's going to mess up the flow, I can always bring it up at the end. What would you prefer?
It's a new topic, or what do you have? Or
it's about. I'll bring it up at the end. No problem.
Okay, I was anyway finished. So there are 3 more I have in the pipeline. I'm gonna push them over the next days, and then we can look at them in the next meeting. But go ahead, David.
I was having a look at the satisfiability algorithm that's in the
Sure.
in this spec, and one thing that I thought about is that yes, that is how it works, but I believe if anyone implemented it on face value, it would it
Oh,
would it would
yes.
it would not work because they would run out of memory or they would run out of time.
Yes. That was a deliberate choice.
Okay.
So when we started discussions on this, we basically said we could write an optimization, like an optimized version, or we could write a very easy to understand version, because the algorithms in the spec, also in the GraphQL spec, by the way, are geared towards understanding, not efficiency, to bring the concept. Like that's also the executor chapter will be very bare-bone, because we don't want to say you have to use Dijkstra, or you have to use a greedy algorithm, or whatever. It's or you build a resolver approach, could also be possible. Maybe not the most efficient thing to do, but basically we don't tell you how to do it. We just tell you enough so we can interface with each other. So this is a rule that you have to follow, but it's not it's not trimmed to efficiency.
Gotcha. Thank you.
There's also, like, for instance, Camel. They did a lot of stuff to cache the passes that they walked along, and we don't even talk about caching or.
Yeah, without memorization, like I think it's not possible to, like, it will work for small graphs, but then as soon as you get into it.
I mean, I'm pretty confident that, I don't know because I haven't looked at it in detail at it, but I'm pretty confident that at least the implementation from Apollo, the guild, and us are fundamentally different in how it's designed, and they wouldn't if this algorithm was specified in a better way. They would all be the same.
Yeah. Also from Query Planner, it's very, very different. It's very, very different. Like the philosophy behind all three implementations is very, very different. Not in the kind this is better or worse. It's more like there's a different implementation philosophy behind these things, it's quite interesting. But I think there's also the place where you want to innovate around.
Yeah, and we did actually think about not specifying satisfiability at all, or actually specifying satisfiability as something stupid like the set of all queries that are valid GraphQL on the supergraph on the public schema must be equal to the set of queries which are valid. Which satisfy, and then we said that we provide some kind of algorithm just to make the spec complete, but purposely not something which is optimized.
Yeah. Also, just as a heads up, I'm at the moment polishing the spec, and we are building a validation framework for it. That was the other thing, because we said we don't build a reference implementation like we have in GraphQL with GraphQL.js. We basically built a validation framework behind that, and that is based, like, I took over what Kamil built for the guild, and we are adapting it to the composite schema specification, and then we're going to add each of these rules as we go along. Awesome. Yeah, and I'm not doing a blame list there. It's just a tool that you can run locally to validate your implementation. Okay. I think with that, we are at the end. If you have anything, bring it up, or we can put it on the agenda for next week. In 2 weeks. In 2 weeks, and just for the US, it's like we do a morning meeting in Europe. I don't know if you can even join.
I'm gonna skip. It's gonna be 6 in the morning for me.
Oh,
and,
yeah.
And 4 a.m. for Sachin. So I'm pretty sure he's gonna skip also, but maybe
Yeah.
he's sleepless and cannot think about anything else about it. So
Yeah, I might be doing other things at 4 a.m., so I might be busy then. Sorry.
No, it's to give Andy
yeah.
the possibility that he can join also and discuss like his things.
Yeah, totally fine. Yeah, sounds good.
Awesome. It was great seeing everyone. See you next week. No, in 2 weeks.
See you later.
Bye-bye.
Bye.